Here we want to convert our mixed radicals into entire radicals. To do that, we look for, in this case with square, we first check the index, the square root. So we look for perfect squares in here. So there's a few different perspectives I can take. I can just say that this is 8 squared. Square and square root cancel each other. I can say that this is 2 squared times a, and then this is b squared times b. And as long as I find perfect square factors, I know that perfect square factors can be undone with the square root. So there's this perfect square, there's a perfect square here, there's a perfect square here. All those can come outside the square root. So square and square root undo each other. The square here is undone by the square root, so I end up with a squared. B squared becomes b on the outside. So inside is squared, outside is square rooted. And so what's left over is I have my 1a here and my 1b, and there it is. There's my answer. So there's some other ways we can do this. We can think of this as, we can just apply the square root here. We can look for square factors. Okay, we can look for even factors, even powers for the square roots here, and groups of the even powers. Here we have the cube root of 125. I'm just going to actually cube root it and get 5. Here I know the cube root, there is a perfect cube of a to the power 3. So I'm going to take out one of those. So I'm going to take out 1a, and I'm going to take out 1b, because that's a perfect cube. So if I can take out groups of 3, that is allowable with a cube root. So I'm going to be left with a squared, because that's not a group of 3, exponent of 3, so then we can't undo that one. Here we have square root. Okay. Well, in this one here, we want to put the powers into. So on the outside it's 2, on the inside it should be 2 squared. Okay, so 2 squared, square root is the same as 2. A squared under the square root is the same as a, and b squared is the same as b. Okay, so all those parts on the outside show up as squares on the inside. We have our a squared, b to the power x as well that we'll have to deal with. Okay, so now we can simplify this. In the square root we have 4 a squared, and a squared is going to be a4. This is going to be b squared squared. And then we have the extra b to the power x. These are the same base. So we end up with 4 a to the power 4. And we count the b's all together as 4 b's multiplied plus x more. We don't know how many that is, but we know that that x number more. So again, on the outside it shows up as 2ab squared. On the inside we have to power it up by 5. So outside is like that, so inside it needs to be the power 5. So and vice versa when we take it in and out. Okay, so we have these terms here are going to show up inside the fifth root, and they're going to show up as fifth powers. So we end up with 2 to the power 5. And again, if we undo those, we're left back at 2, which we started with, which is what we want. Same here, if we undo the power 5 and the root 5, we end up with a. And then this becomes power 10. If we apply the 10th power and the 5th root, we end up with b squared. Okay, and again, this is all connected by multiplication. Okay, if there was a plus or minus in here, we should be worried, okay, because that's a big problem if we have pluses and minuses in here. So now that we've got the outside inside by powering it up, we can just combine the bases that are the same. So we have 2 to the power 5 times 2, that's going to be 32 times 2, which is 64. A5a squared, that's a total of a to the power 7. We have b to the power 10, and then c to the power 4. Okay, so there we go. Okay, so I did mention one thing then, just to be careful of this. When we have pluses and minuses, we cannot square root. Okay, so if I have something like this, 9 plus 9a squared plus 16b squared or something like that, 16c squared, the plus does not allow us to apply exponent rules. Okay, we cannot square root, we cannot power when there's a plus in here. There's nothing we can do. Okay, so we can't. Okay, so we can't do anything in this case. When we can apply powers is if we have multiplication. Okay, so if I had something like this, on the other hand, 9a squared plus 9b squared, okay, I cannot apply the square root across that plus. However, if I can express this as multiplication, or in other words, factor, okay, so now I have a times here. That 9 is a multiplying factor. A squared is not a multiplying factor, so we cannot do roots on it. So I can then apply the square root to the 9, but then I'm still stuck with that plus, so we can't do any squares or square roots across that plus. Okay, so it's the same thing here in the opposite if I had something like this, a plus b squared. Okay, the rule is the same. I cannot square across the plus minus. Okay, squares and square roots are not compatible with add and subtract. We can do something when there's times and divide, so that's why we factor here. Okay, but whenever there's plus, we cannot apply exponents or square roots across any pluses or minuses.